In this video, I will go over a few questions on the final exam practice. The first one is question 15. It is commonly believed that the mean body temperature of a healthy adult is 98.6 Fahrenheit degree, and you are not entirely convinced. You believe that it is lower than 98.6 degree. And the temperatures for 12 randomly selected healthy adults are shown here. Assuming that the distribution of the population is normal, so you don't need to do the checking using the box plots or the normal probability distribution. But now we know that we can use the t-test for the population mean, because the population standard deviation is not given, therefore we use the t-test. If the population standard deviation is given, we use the z-test. The null hypothesis is when you assume that the mean is equal to the original assumption of 98.6, so mu equal 98.6. And the alternative hypothesis is when you say that you believe that it is lower, so mu is less than 98.6. This is pointing to the left, so we know that this is the left tail. Okay, so how do I do the test statistic? Well, I can show you how to do this on the TI-84. First thing is you need to go to Stat, Edit, and then go ahead and enter the 12 value that we have here. This is the 12 sample from the collection for the analysis. 93.8, 88.2, 95.7, 98.3, 97.9, and 76.9. And now to perform the t-test, we go to Stat, we go to Test, and I know that I have to do the t-test, right? This is the z-test, one proportion z-test, the interval, and so on. But we are looking for the t-test, so we use the second option, and we use the data, and the original assumption of the mean is 98.6, and the data we put it on the list A1, so that is good. And this is the left tail, so pointing to the left, and you want to calculate that. So the t-statistic, the test statistic is minus 3.658 right here. The p-value is 0.0019 if you route it to number 8 to 9, 0.0019. And the alpha level in this case is 0.05. 0.0019 is less than alpha, right? It's less than alpha. The p-value is less than alpha, therefore we reject the null hypothesis. If we reject the null hypothesis, that means then that means we have enough evidence to support the claim that the temperature is lower than 98.6. The second question that I want to go over is question 36. The average American gets a haircut every 38 days. This is the mean value. Okay, is the average different for college students? The data below shows the results of the survey of 13 college students, asking them how many days elapsed between the haircuts. Assuming that the distribution of the population is normal, so we do not need to check for the normal probability plot. And this is the sample that we collect for 13 college students. Now again, we don't know anything about the population standard deviations, so we should use the t-test for the population mean, the null, and the alternative hypothesis. So first we assume that the mean for the haircuts is for every 38 days, so mu, the mean, is equal to 38, and we are looking to see if the average is different. That means this is the assumption that the mean is not equal to 38, right? This is different size, so this is 2 tails. So again, we can perform this using the TI-84. Very easy. So I go to Stat. Now, if you want to enter the value in the list A1, first you need to clear the whatever the value that you have on the A1. So use the clear list functions and then pick A1. So make sure you clear everything. And now go back to Stat, Edit, and now you want to put the value of the today here of the 13 college students. 35, 37, 37, 35, 41, 37, 25, 40, and 32. So you have everything here. Now again, we know that we are using the t-test. So go to Stat, go to Test, and go to z-t-test. And then again, we use the data, and the mean is 38. This is the original assumption. And you put the data in the list A1, and you want to test to see if it is different. So this is the 2 tails. Make sure you pick the different side here, and then hit calculate. So your test statistic is minus 1.1089 right here, and the p-value is 0.2892. And the alpha in this case 0.01. This is the p-value is bigger than alpha. If the p-value is bigger than alpha, we fail to reject. We fail to reject the null hypothesis. If we fail to reject the null hypothesis right here, that means we don't have enough evidence to support the claim that the mean, the average is different from 38. So the data suggests that the population mean of the days between the haircuts for college students is not significantly different from 38 at the alpha level of 0.01. So there is not enough evidence or insufficient evidence to conclude that the population mean number of days between haircuts for college students is different than 38. Okay, the last question that I'm going to solve is 37. A statistics teacher claims that on average 20 students in his class get an A, 25% get a B, 35% get a C, 10% get a D, and the rest get an F. The race of a random sample of his students over the years is recorded. That's the claim at the 10% significant. So first thing is we need to fill out this table. We have 1, 2, 3, 4, 5 different categories, and the observed frequency is obtained right here. And we need to look for how to find the expected frequency. So first thing is you need to add all of the frequency to look for what is the sample size. So 70 add 31, 41 add 114 add 14 and add 33. So we have a total n of equal 272. Now to find the expected frequency, remember the expected frequency is found by taking the probability multiplied to the total number of the sample size, or the total number of the frequency. So we have 20 students would get an A. Okay, so we have 0.20 because that is 20%. This is P, and multiplied by N, the total is 272. So you would get 54.4 is your expected frequency. And then we know that 25% would get a B, so 0.25 P, the probability multiplied by the total sample, the total of the frequency 272, and that is 68, and that is the expected frequency for B. And then do the same thing. We have 35% get a C, so 0.35, and then multiply 272 and you get 95.2, and then do the same thing for 10% for D and the rest for F. You would be able to get this number and this number. Now, how do I find the test statistic, the degree of freedom, and the p-value? Well, this is the goodness of fit test, so we can apply the function on the TI-84 to help you to find the test statistic and the p-value. Now we have 5 different categories. So to use the goodness of fit test, first thing is we need to go to Stat, Edit, and then the list of L1, you want to enter all the value of the observed frequency, 70, 41, and then 33. And then for L2, you want to enter all the expected frequency. So all the number here, you must enter over here. So L1 is the observed frequency, L2 is the expected frequency. And then you go to Stat, and then go to Test, and scroll down and pick the option of the chi-square goodness of fit test. The observed one is L1, the L2 is the expected frequency. And I know I have 1, 2, 3, 4, 5, so 5 calories. Therefore, the degree of freedom is 1 less than that, so 5 minus 1, which is 4, right? 5 of them, subtract 1, so it's 4. And then you just hit calculate. And the chi-square will give you the test statistic of 26.5494, which is that number right here. And the degree of freedom, we know that this is 5 calories, so subtract 1 is 4. The p-value is 2.45 times 10 to the negative 5. This is small, right? 2.4 times 10 to the negative 5. So you move 5 places to the left. So that is like close to 0. And the p-value is 0. You can think of that as 0 because it's very small. And then test the claim as the 10% significant. So that is 0.1. So in this case, the p-value is less than alpha. Alpha is 0.1. P-value is only 0. So p-value is less than alpha. If it's less than alpha, we reject the null hypothesis. So the decision rule should be reject the null hypothesis. If we reject the null hypothesis, we can answer this question. Does something significant happens? Significant happens because we do reject the null hypothesis. And the conclusion is there is enough evidence to conclude that the teacher's distribution of the race are not as the teacher claims. Okay, because we reject the null hypothesis. We reject the null hypothesis. Therefore, we say that okay, we have enough evidence to say that whatever the teacher claims may not be true, so that the teacher distribution of the race are not at what the teacher claims, because we reject the null hypothesis.